going to write programs. And I've said that a program that you're going to write will be a solution to a problem. And this solution is going to run on a computer system. And why this solution is running on a computer system is for us to harness the benefits of computer systems, their past and correct. So in this class, so we'll just look at the course outline. So this will be a 12-week class, you know, kind of 12 week, and we are actually in week 2. We are actually in week 2. So week 1 was last week, but this is where we are going to catch up. So when you look at the course outline, so when you look at the course outline, so just a minute. Okay, so there's something I wanted to. So we look at the course outline. So for this, I'll put it in weeks. So our first class is an introduction. So in this introduction, so just look at what a computer is. So look at programming methods and programming languages. Again, there are different ways or different styles of programming. We have different programming languages. So in this introduction, again, we look at what a problem is. So analyzing a problem. After the analysis, there's algorithm development. So that goes into week 2 or the second topic. The algorithm design and testing. So I've said that an algorithm is like a recipe. After you design it, you test whether it's correct. Actually, if you're cooking something for the first time, you may not be sure whether the outcome will be correct. So you go through the steps, and at the end of it all, check whether so the outcome is what you had desired to create or to cook. So the same thing with an algorithm. So when you have a problem, you created an algorithm or you've written an algorithm for it. You test whether it is correct. So we look at that, and then after that, we go into now the programming world. We look at the structured program design. We look at what is known as integrated development environment. So using CodeBlock. So CodeBlock is a platform for writing programs. It's an open source platform. So in this CodeBlocks, there are different tools. So when you're writing your program, you require different tools. So we'll look at that later on. So the different tools are within CodeBlocks. That's why it's called Integrated Development Environment. So there are tools for writing your instructions just in natural language, and for this using some programming. Full screen. So when I'm on full screen, I may not be able to see the chat wall, but now I've dropped the full screen and I'm seeing all manner of reactions. So very interesting, right? Yes. So like I said that, so in this class, so there'll be some what are called ethics, right? So they're what are called ethics. So when there's an issue, to just raise the issue. So don't make other people laugh. So we are not in some just for laugh conference, right? So Joseph, I see your hand raised. You want to say something? Joseph, you want to say something? Okay. Okay, fine. So I'll just repeat. So it's like we lost each other at some point. So what else we started? So let me go back to the course, the plan. So how we'll conduct this. So this will happen in 12 weeks. And for each week, in the course outline that I'm going to share, so we've indicated so what will happen in every week. And so allow me to go full screen. So I hope I'll not get lost again. So in the first class, so we'll give an introduction to what computers are. We just look at the components of a computer system. A computer is a system made up of different components that are interrelated, and each of the components of a computer system has a specific function. So like we have the input devices as a component of a computer system, and the work of the input device is to accept data. We have the processor as another component of a computer system, and the work of a processor is to transform data from one form to another. We have memory, another component of a computer system for data storage. We have output devices, for uh, for giving the output or the results of computation, and also we have some other peripheral devices within the computer system. So I've said up to that, we look at what a problem is, so what problems can be solved using a computer. Again, not every problem can be solved directly using a computer system. In understanding problems, we'll create or write what are called an algorithm, and I've told you earlier on, just equate an algorithm to a recipe in a kitchen. So an algorithm is a set of steps to carry out a task. A set of steps to carry out a task. So for example, if you have a task to go to town, from MMU you want to go to town. So you can write an algorithm for that. That from my office I want to go to town, so first I'll think about the means. If I want to go to town by mat, yes, so my steps will be I'll get from my office, walk to the bus stop, wait at the bus stop for a bus to come in, board the bus moves, I stop somewhere, I alight, that's the algorithm. So we spent some time in writing algorithms, understanding what algorithms are. And every algorithm is a solution to a problem. And at the end of the day, you have to test that you have the right solution. So there's what's called algorithm testing. We have structured program design. So after you write the algorithm, you translate the algorithm using some programming language. Now you go into writing a program. And for this, there's a design that is followed, and that is what is called, in the introduction, structured program design. We look at the program development life cycle. So a program has a life. It's a cycle, it's endless. And so the reason why it's a cycle, because things change. Right? So when something has changed, the program must be changed or needs to be updated. So we look at that, then we look at C, it's a programming language. So we look at the environment that we're going to use to write our programs in C. And this is called CodeBlocks. So CodeBlocks is a platform that has different tools for writing programs, specifically programs in C and C++. But for us, we start with C. I'm going through the course outline. I'm going through the course outline. I believe I'm not lost. So someone is giving a comment there that I'm lost. So let me see a comment there that I can be heard. So I don't think I'm lost. So I need a feedback there. So if the noise, if my voice is breaking, okay, so maybe my internet, but I think it's good enough. Okay, good. So we continue. So in writing our programs, we're going to use a programming language, and then the language we're going to use is called C. So I'll explain this later on. So what a programming language is, yes. But at this point that you're just going through the course outline, just get to know that the language that you're going to use, the programming language that you're going to use is called C. There's also C++ that you're going to learn. Here you're also going to learn Java in class. You're also going to learn Python in class, plus any other programming language. And the good thing with a programming language, when you have one, like now at the end of this semester, you will have the C programming language. It will be so easy to learn any other language. So don't be limited by what you have in class. You should actually explore. So don't be limited by what you have in class. Be ready to explore. So after getting to know about programming as a problem-solving activity, that's what it is. When you're writing a program, you're solving a problem. So devising the solution as an algorithm, then now you go to coding. Now, the coding now is now when you'll be using some programming language to write the instructions. And in this case, you're going to use C. And I'll say that we will go back to the function of a computer system that accepts data, transforms the data, and gives an output. And that's how our programs will look like. The instructions you write will be an instruction to get data from the input device, an instruction to process this data, an instruction to store this data, an instruction to output the data. That's how a program will look like. So you have the set of instructions that will do the inputs, set of instructions that will do the processing, set of instructions that will do the storage if need be, right? And set of instructions that will give the output if need be. So at the end of the day, our solution will be running on a computer system. And if you go back to the function of a computer system, all that will come in play in form of a program. So you'll find that when we'll be now getting to coding, we'll be interested in how you're going to manage the data, right? And for this, what comes are how data will be stored, or where will this data be held, right? If I'm thinking about a recipe in the kitchen, I need to cook ugali, so we'll be thinking about the container that will hold the water, a sufuria, right? But now for here, we call that a variable. What container will hold the data? And then we also have two types of data. We can have fixed data, fixed value data, and variable value data. So fixed value data will be called a constant. So the container that will hold such data will not change. And then a container that will hold a variable value data will be called a variable. So there, the value can change. And then we're also saying that data will occur in different types. So we have data, numerical data, we have data in text form, we have data in audio, we have data in video. So for a start, so the kind of data that you're going to work with in this class will be mainly in numerical form. and a bit of text somewhere. But the bulk of the data that you're going to process, that the programs that you're going to write will process, will be numerical data. So data in other forms like audio and video will come in other advanced units in your curriculum. But again, there you'll find that audio data, video data will be coded into numbers. So at the end of the day, just this about numbers. And again, even for numbers, we have whole numbers, we have decimal numbers. All that is taken care of. So this data will be transformed, will be processed, and that's how the operators come in. When you look at week 4, there's a topic on operators. And operators will transform data. And we have different operators. We have arithmetic operators, the addition, subtraction, multiplication, division. All those are arithmetic operators. This is the mathematical operators. We also have relational operators that is supported by the CPU. And relational operators are used to compare things or to compare values. And such operators include less than, greater than, equal to, not equal to, less than or equal to, right? And whenever a relational operator is used, the result of evaluating such an expression is a true or a false. We also have what are called logical or conditional operators. So these operators combine quantities. So they combine values that are true or false. So they're called logical operators. So we'll get that. So we'll work with, so the programs you're going to write, when you're now the bit of transforming data, you can either use arithmetic operators, relational operators, or logical operators. Then after that, I said that at this point, there'll be a task for us that will be assessed in form of a CAT, so that is continuous assessment test, before we carry on. And then next, now we go into the structured program design. Now at this point, we're thinking about how do we organize the steps? How are the steps organized in a program? How are the instructions arranged? How are the instructions executed? The order of execution. And I've said that view a program as a set of instructions. If we are thinking of a set, there's 1, 2, 3, 4 until n. So you have instructions 1 to n that make up a program. So how are these instructions executed? So 3 ways these instructions can be executed. So the first is sequence. So in sequence flow, instructions are executed one after the other. I've said that we've numbered our instructions 1, 2, 3 until n. In sequence, 1 execute, 2 execute, 3, 4, 5 in that order. That is sequence. And for this, there are problems that will require that the steps to the solution of the problem are carried out in sequence, one step after the other. So that is sequence. So another way, the second way is selection. It's called selection or decision, also called branching, but the most popular word that is used is selection. So in selection, the execution of a step depends on a condition. The execution of a step depends on a condition. So when you have step 1, 2, 3 until n, you may find that some steps may be skipped. Some steps may be skipped based on a condition or a set of conditions. So that's selection. So we find that 1 executes, 2 executes, 3 does not execute because a condition is false, or 3 executes because a condition is true. And then next. That is called selection. So we'll go through that. And then thirdly, there is repetition, another way that these steps can be executed. In repetition, you find that a step or a set of steps is executed more than once. Repetition. A step is, or a set of step is repeated. And again, there's some tasks or some steps in a solution to a problem that may require repetition, that some things are done more than once. Again, we look at some set of problems when we reach there that will fall under repetition. And again, with repetition, there has to be a condition that must be true for a step to be done again. Just the same as in selection, that there must be a condition that must be true for a step to execute. So you'll find that there are some problems that will only fall under sequence, or may only fall under selection, or may only fall under repetition. But most of the time, you'll find that all the three will be required in a program. So in a program, some steps may follow one another in sequence. Some steps may be branching, that is selection, executing or not. Some steps may be done more than once, repeated. So that's what is called structured program design. And that will be done, and this is the backbone of any program. The control structures, they're also called control structures. So control structures are the backbone of any program. So the sequence one is a bit straightforward. Yeah, it's actually straightforward, one after the other. Sequence, I've said that there must be a condition. And for this, the specific concepts that are used to implement selection. So if you look at week 6, it's talking about control structures 1. That is just numbering. And in this, it's saying selection. And for selection, we are going to use what is called an if statement and what is called a switch case statement to implement that. And then again, what is not so straightforward is repetition, also called iteration, also called looping. 3 words. You can either call it iteration, call it repetition, or call it looping. Again, for this, the specific statements that are used to implement this in a program. You can use what is called a for statement, you can use what is called a while statement, you can use what is called a do while statement. And reset loops are some specific statements. So they do some key roles. So we not explain that here. That's what is called a break statement and a continue statement. You use these two statements when you're working with loops. So we'll get to know what they do in a loop. I've said a loop is a group of statements that are repeated, or a group of instructions that are repeated. Then at this point, we can write any program. So having looked at the control structures, given any problem, you can be able to write a program for it in any programming language. And for us, I've said that we're going to use C. Because at this point, we actually look at the building block of any computer program. We've thought about how data will be managed in the program. So what containers will hold fixed data, the constant, what containers will hold variable data, the variables, how data will be accepted into the program that's using the input operations. So how data will be stored in the program that is in the containers that are either variable or constant. So how the output will be given, and that is the output operation. And then how the instructions in the program will flow, either in sequence, selection, or repetition. So we can be able to write a program at this point. So in fact, at this point, again, there will be an assignment or some small project to do just writing a program. And then what is coming after this is just ways of now making our programs more efficient in terms of managing the data, in terms of managing how to organize the data and how to organize the steps. Yes. So there are two things in a program. So there's the data and the actions to be performed to transform the data. So when you want to make your program better, you can either think about organizing the data so that it can be accessed and processed efficiently, or even thinking about the steps, how to put the steps together again to enable efficient execution. So related to the steps are what are called functions. So a function is a sub-program, yeah? And you use functions when you have a very big problem to solve, and solving a problem is writing a program. So instead of writing a long program, a huge program, you can divide the program into different parts. And the reason for subdividing into smaller parts is to be able to manage the smaller parts easily. So when you have something small compared to something huge, it's usually easier to manage. If you are tilting land, yes, you have a whole field and you're asked to tilt it. So I think you will get tired before you begin. But if this land is separated into parts, right? Into parts, smaller chunks, you're told to do chunk A first. I think it will be easier for you to manage other than looking the whole field at once. So the reason why, yes, so at the end of it all, when you have your program, instead of writing a long program, it will be easier to write it in smaller parts. And now you use what are called functions to represent the smaller parts of a program. And then later on, all these functions are combined together to form the larger program. So that is related to managing the actions that will transform the data. So any related thing is put together into what is called a function. So that will get when you get there. And then when you think about the data, again, you can also organize this data into some containers, yes, to make access easy, but when to make manipulation of the data easy. And for this, you use what are called arrays. So arrays will relate to organizing data, and use an array to organize data of the same type. If they are numbers, they must be whole numbers. You put them into one container called an array. The opposite of an array that will not get time to do is called a structure. So a structure will hold data of different type. But unfortunately, we will not be able to look at structures because time will not allow us. But I know there's another programming unit that you're going to explore structures in detail. Then we have, so lastly, if time will allow, so if we move very fast, then we'll go to our last topic, string and pointers. So a string is a group of characters. So a character is a letter, is an alphabetical letter. That's a character. A character can also be a number. A character can be the special symbols. So like if you look at the keyboard, we have some other special symbols. Right? So all those form characters. So you can have an array, or rather a group of characters. I don't use the word array, but later on we'll see that a string is a group of characters, and in a good term we call that an array of characters. So like now, if you want to write your name, if you want a program that will accept data in form of text, so for that you use what is called a string. And text is just a group of characters, is having letters and even the white space in it. So if time will allow us, we do that. And for this, we have some special operations that can be done on strings, like a name. You can convert a name into lowercase, you can convert a name into uppercase, you can return the length of a text, you can reverse a text, you can combine one text with another one. There are different operations that can be done on text, also known as string. Then we have what are called pointers. Again, this is a very interesting thing for a programmer. So pointers will be used to manage memory. So when you're writing, a program will require memory because a program will use data. So when this data is accepted by the program, this data will go into memory. After processing, this data will go into memory and everything. So that's how you can manage this memory early enough in your program. At the time you're writing a program, memory can be allocated, and that we call static memory allocation. So that is memory allocated. By the time you're writing your program, you're translating it into the machine language, the program has memory. That's static memory. We also have so there's also the dynamic memory. So this is memory that is allocated at runtime. So your program will undergo different phases. So at first you write the source code in some programming language, yeah. Then after that, the source code is compiled for C. The process is called compilation, translating the source code into the machine code. The process for C is called compilation. And then after compilation, then if it is successful, then the program will go to the runtime mode. So you can write your program in such a way that you only want your program to have memory at runtime, or even to have memory at the compilation time. That's how you put your program. So there are some problems that will need you that the program is allocated memory at time. And for that, you use special variables, they're actually variables called pointers. Yeah, they are containers, and a pointer will hold an address, a memory address. And in memory, what will be held in memory is data. If you have memory X that is holding a value 60, a pointer will hold the address of X. So memory have numbers, and the numbers in memory are called addresses. So if you get time, yes, so this will depend how fast you're going to grasp things, then you're going to do pointers. But if at all we don't make it to do pointers in this introduction class of ours, we still have a programming unit ahead where we're going to do pointers very well from the start. So that's what we'll do in this class. So writing programs and at the basic level. So it should just be at the basic level. And for you to write a program at the basic level, you need to understand how to organize the data into variables and constants, how to accept the input data, how to process the data using the operators, the arithmetic operators, the relational operators, the logical operators, that's processing. Then how to output data. And outputting the data, you need the output operations, right? And then now, how to make it happen that we write a program to accept data, write a program to process the data, the program stores the data, the program outputs the result. That's how our program will look like. Our program will accept data, a program will process data, a program will store data if need be, store data, a program will output data. So when you're writing the instructions, so that a program is a set of instructions. So the instructions you're going to write will be instructions to accept data, instructions to process data, instructions to store the data, instructions to output the data, and that will make up the program. And now when you're writing these instructions, the control structures will come in play. So there will be, these instructions will be executed. So how will they be executed? So there will be instructions that will be executed in sequence. There will be instructions that will be selected for execution, others will not execute at one moment in time. There will be instructions that will be repeatedly executed. So I hope you're together. So that's what a program will be. A program to take in data, a program to process the data or store the data, a program to output the data. And as we write this program, for every instruction, we have in mind how the instruction will execute. Will it be in sequence, in selection, or in repetition? That's at the basic level. Then after that, when you're okay with that you can write a program, now we'll go ahead and think about writing good program. So a good program is a program that is reliable. When you think about reliability, you think about correctness. And also when you think about reliability, you're thinking about efficiency. And I've said, when I think about efficiency, it can be about how you organize the data or how you organize the actions that will manipulate the data. So now the concepts of functions coming in, the concepts of arrays coming in later on. And then lastly, so how to deal with the text data. So looking at text as an array of characters. And then for some specific problems, we'll see such problems that may require that you think about at what point will the program need memory. Is it at compile time when you're doing the translation, or when you're running the program expecting the output? So that's now where the pointers will come in. So that's what we'll do in the next 11 weeks coming up. So for this, your dedication is required, your stamina very key. So they say, so for you to be a true programmer, so there's a good programmer and then there's also a true programmer. So a good programmer has a mastery, of a programming language. Like in this, you're going to use C. Those are true programmer. So you have a mastery of C. So a programming language, let me just say at this point, just like the natural language has the structure and form. Like the words that make up a language, how are they structured? Yeah, so just think about how you learned English. That when you have a noun, the next thing should be a verb or something like that, right? So that's how a programming language is also organized. So there's a syntax. So how the words that make up the language are organized to make a meaning, to make a form. So that's the meaning. So at the end of the day, you put these words together and have the right meaning. A programming language also has the two forms: the structure, the organization of the words to bring out a meaning. So like if you want to write an instruction to accept data, yes. So what terms are you going to use that will make this happen at the end of it? Yes, so a true programmer will have a mastery of that. a mastery of the English language, I believe you have that so and so is so good in written English. But if you are in a conversation, you go into a debate, it becomes very hard for you. But when you're down to writing like a composition, very nice, right? But when you go into a debate, it becomes tough. Yes, so a good programmer will have a mastery of a programming language, say C. But a true programmer is a problem solver. So a true programmer is a problem solver. So that at the end of the day, you're not just going to write a program. The program will be a solution to a problem. So if you're able to have a problem, there is a problem. You're able to analyze the problem. You're able to come up with a solution to the problem. And then now, lastly, just rewrite, not write, rewrite the solution using a programming language. Then you become a true programmer. So a good programmer will just do the last thing, can only rewrite a solution to, can only rewrite a solution using a programming language. But a true programmer will understand the problem, will come up with the solution, and will rewrite the solution using a programming language. So I usually encourage us that for this, so let's strive to be true programmers. So let's strive to be problem solvers. And this will require your dedication. You've seen the timetable that we are meeting on Monday. There's a group I'm meeting on Tuesday and another one I'm meeting on Wednesday. And so the emphasis is actually to the lab session, not with the theory on Monday. To know that it's a practical class, the Tuesday, Wednesday class must have for you very key. Your dedication required and your stamina. So a programmer, you must have the stamina. You'll be writing this solution, you think, because you've seen somewhere that we have to test. Yes, you have to check that your solution is it's actually the solution. So you write the algorithm, you test whether it's the correct algorithm. So sometimes you do the testing, things are not working, you write your code, you're not getting the expected result, you have to go back, try to understand the problem, revise the solution again, do the testing, so do this until things work. So that's why they say that as a programmer you must have the stamina. You cannot give up. And for this, you're going to think programming every day. So as much as you're thinking about it, as per the timetable, Monday, Tuesday, Wednesday. So for you, I want you to think about it every day. And programming is just like maths. Yes, it's just like maths. So just think about the effort you put in maths compared to English, or even those who did history. So how much effort did you put in your math exercises or your math classes compared to your history, those who did history or geography classes? It's about practice, 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 practice. There's no shortcut. Practice, practice, practice. And for this, you can't sit back and say that you're going to cram anything. So nothing to be crammed. If there's a concept So like we talk about repetition. That's how it is implemented. There are statements that can be used to write a repetition. And then there's a structure how that should take form. You can't cram that. Yeah. But when you practice, you use what is called a loop for different problems. You understand it well, such a way that if you get another problem, it will become obvious for you to use a loop. A loop is used for repetition. So practice is very key. And you find that every time we meet for a lab session, you'll be carrying out some exercises. You'll be carrying away like homework, some exercises to just help you practice. And I must say that we are lucky enough that resources are available for us, that you don't have to be in a lab to write a program. So today you can be in a matatu. Yes, so like those matatus of Rongai, I hope you've experienced them. They make a lot of noise. So if you just want to have your peace, you can just write some short code and run it as you go to town. Yeah, so just love programming, just love it, and do it anytime you have time. Do it anytime you have time, right? I know you have some other things you have to do. If you have some free time, just do it, just practice. So for us, we are going to prepare for this. So in the lab, we have our computer labs that we are going to use. And then let me just tell you that there, the machines are not enough for everyone. As much as we've even gone into groups, that the class is divided, so each class is in 2 groups. We may find that we go into the lab, some machines not working correctly and all that. And for this, I believe most of us have smartphones, and some of us have their own laptops. So those who have smartphones, so there's an app in Google Store called Coding Say. There's an app called Coding Say. Just Coding Say. It's in Google Store. So just download it. We also have, so like now for that app, you'll have access to the C compiler. So there's also a web access to the C compiler. So let me just get the URL, confirm it, that you can use. Yes. So when you go to this site, so let me just write it here. Yes, Coding C. So there's also another site that I see students using. That has an online C compiler, and it even has tutorials you can use. Let me just get it. Let me confirm that is the correct one. So it's actually Program Maze. Yeah. So this is it. So not what I've written there. So this is the right one. Yes, so I see Nick has also put something there, freecodecamp.org. So it's programme.com. Yes. So this you'll find online compilers. You'll also find even tutorials. So that's the good thing about it. So you have tutorials explaining different problems, and then you also have a chance. There's an environment where you can write your code and compile and get the output. So otherwise, in the lab, there's now if you have your laptop, there's code blocks. It's open source. So this is an IDE. Integrated Development Environment, code blocks. So this is a platform that has different tools that you need to write a program. And with code blocks you can compile C programs and C++ program. So with your laptop, it's open source, code blocks, so you can download and install code blocks. And even the machines in the labs that's what is being used. But any other, so like now we'll be doing C. So any other C compiler will just come in handy. So for this, you'll have no excuse. I know, so there'll be three resources for you. It's either your smartphone, which I know almost all of us have smartphones, yes. Come tomorrow, so the group I'm meeting tomorrow, coding C. Have it ready on your phone. Your laptop, those who have laptops, the few that have laptops, download and install code blocks. Right? Or if that is not available to you, we'll have the machines in the lab. But I'm saying that the machines in the lab will not be enough for all of us. So that's why we have to supplement with our phones and our laptops. So just a minute.
You are currently the only person in this conference.